Okay, in this video what we're going to do is we're going to take a look at some different types of techniques of differentiation. We have three rules specifically that we're going to be using that allow us to find the derivatives of more complex things, not just power rule or a constant or a line or something like that. So the first is called product rule. And right now, with product rule, oftentimes you can multiply out the binomial and a trinomial or something like that, and you can simplify it and then take the derivative, and that's probably easier to do. But down the road, you're not going to be able to do that. Like you're going to have like x squared times the sine of x, and you can't multiply those out. So what product rule says is that if you have a function h of x, and it equals the products of two other functions, say f of x times g of x, you can find the derivative of h by find the derivative of f, find the derivative of the first function times the second function, plus the derivative of the second function times the first function. Like I said, for our initial problems, a lot of times it's easier just to simplify them and not do the product rule, but down the road you're going to have to use the product rule. Let's take a look at an example of that. Let's say that I have f of x, and I'm going to make it as complex as I can just to make it hard to simplify, is equal to 3x squared minus 2x plus 1 times x cubed minus 5. And to multiply this out would require you to distribute the binomial and the trinomial, combine like terms. It's a little bit of a pain in the butt to do. So I'm going to take the derivative by using product rule. My first function is the 3x squared minus 2x plus 1, and then the second function is the x cubed minus 5. So the derivative f of prime of x, I take the derivative of the first function, which is 6x minus 2, times the second function, which is x cubed minus 5, plus the derivative of the second function, which is 3x squared, times the first function, which is 3x squared, minus 2x plus 1. And then I go ahead and multiply that all out. I FOIL the first part, I distribute the second part, and ultimately I would combine my like terms and I would simplify it to 15x to the fourth minus 8x cubed plus 3x squared minus 30x, that's a 30, minus 30x plus 10. And yes, you do have to simplify to that level because remember, a large part of your exam is going to be multiple choice. And on those multiple choice questions, they're going to simplify that far. On my tests and quizzes, I expect you to simplify that far. Down the road, we're going to be solving our derivatives. So we're going to set them equal to 0, and we're going to solve them, and you have to simplify that far. So yes, you have to do that simplifying. The algebra is probably what gets people the most trouble. And as I come around and I help you over the next couple of days, make sure that you get any help with the algebra that you need, because really it's the algebra that gets in the way of you getting the right answer, not the product rule. Our second technique is going to be quotient rule, and with our quotient rule, it's when we have something divided by two functions divided by each other. And with the quotient rule, if we have h of x equals f of x divided by g of x, then I can find the derivative of this. Oftentimes you can't simplify these rational functions, so you can find the derivative of this h prime of x is equal to f prime of x times g of x minus g prime of x times f of x over g of x squared. So what happens in this is that we're going to find the derivative of the whole function. We take the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator squared. Let's take a look at an example of that. Say we had h of x – 2x plus 3 – 3x over x squared minus 1. So h prime of x would be the derivative of the numerator, which is 2, times the denominator, which is x squared minus 1, minus the derivative of the denominator, which is 2x times 2x plus 3, over x squared minus 1 squared. Multiply out the 2 in front here and the 2x there, combine all your like terms, and what I ended up simplifying it to was negative 2x squared minus 6x minus 2 over x squared minus 1 squared. The third rule that we're going to take a look at today is called the reciprocal rule. And usually with the reciprocal rule, you don't have to use the reciprocal rule. This is not a rule that you have to learn necessarily, because you can always use quotient rule. But this is just convenient when you have a constant on top. So with reciprocal rule, let's say now h of x is equal to 1 over g of x. Then the derivative is going to be negative g prime of x over g of x squared. That 1 on top can be any constant, because remember, you can pull the constants out front. So let's say tell you this time that I have h of x equals 5 over 2x plus 3. Really what that says is 5 times 1 over 2x plus 3. And remember, with our derivatives, we can pull that 5, that constant right there, out front. So I'm really just taking the derivative of what's in parentheses right here. So h prime of x is going to be, it's negative 5 times the derivative of the numerator, or excuse me, the derivative of the denominator, which is 2, over the denominator squared. So it's 2x plus 3 squared, or negative 10 over 2x plus 3 squared. Again, like I said on that last one, is you don't have to use reciprocal rule. You could have used quotient rule there; it would have been the same thing. Khan Academy has some great examples. I think his notation might be slightly different than the notation that I use, maybe slightly different than the notation our book uses, but the same general concepts. So there you go. Good luck on the next assignment, and be back real soon.